When teaching students how to calculate the median, I usually wait until after the first test. I let them watch me sort the Scantron forms from lowest to highest. They don't usually ask me what I'm doing because it is obvious. But the next part is the real teaching. I put the test scores on the blackboard using a simple stem leaf plot. And I don't tell them what a stem leaf plot is, but they all see me looking at each and every Scantron form. And they see me copying their test scores into the plot. Without even explaining the concept, they figure it out right away. And then the next step, I ask them what the median is. How do we find the middle number? I ask. Then, of course, I count up the sample size and show them the median formula based on whether the sample size is odd or even. Using their test scores, they pick this up right away also. Why? Because the data means something to them. It's not about chocolate chip cookies and soda. It's not about marbles in a jar either. It's about how they relate to their peers. And as primates, that's a whole lot of personal investment. And so with this method of teaching, we have the median and we have the stem leaf plot. And they pick it up so quickly that you have plenty of time to go over test questions too. But I always leave them with one lingering idea that I want to leave you all with. I ask them to calculate the mean. In a class of about 30, well, nobody wants to do that. And so I ask them, why do we even bother with the sample mean since the sample median is just so much easier to calculate? And I almost never get a good answer from my college students. And I ask you that question now. Why even bother with the sample mean since the sample median is just so much easier? I'll give you the answer. If we are dealing with normally distributed populations, then the sample mean and the sample variance contain all the information from the populations. And statisticians have a term for this concept. It is called the sufficiency principle. And in the language of statistics, statisticians say that under the assumption of normality, the sample mean and the sample variance are jointly sufficient statistics. But there is another reason to use the sample mean rather than the median. And this reason has to do with statistical hypothesis testing and power to detect the alternative hypothesis. And this is the real practical reason why we use means. You see, under the assumption of normality, well, our standard parametric tests based on sample means and variances are more powerful than their non-parametric analogs under the assumption of normality. Remove the assumption of normality, and you may be better off dealing with the median. So there's a little corollary to this in the first statistics course. Make sure they know that the median is standing by just in case that beautiful normality assumption fails. And until our next episode, this is 11 Labs for Dr. J. Lee Noose.